It triggers the same neural pathways as touching a hot stove. It makes you sweat. It makes your heart race. This is the biological weapon plants developed for survival, yet we crave it. That microscopic spray is capsaicin. It's the chemical engine of pain and pleasure that powers a global obsession. And this is where that obsession is fed. Humans consume over $3 billion worth of hot sauce every year. This isn't just cooking. This is precision engineering on a massive scale. We are about to follow the journey of a single red chili pepper, from the genetic science in the soil to the high-speed bottling line. It begins here, in the lab. This isn't just farming, it's genetics. Before a single seed is planted, scientists spend years developing cultivars optimized for flavor, color, and, crucially, heat consistency. These saplings are clones, ensuring that every eventual bottle of sauce tastes exactly the same, whether bought in Tokyo or Texas. Uniformity is the first requirement of industrial scale. In the field, the peppers are solar panels storing energy. They are left on the vine until the absolute last moment to maximize sugar and capsaicin levels.
As the weeks pass, captured in this rapid sequence, the vibrant green slowly yields to a deep.
We monitor sugar levels daily. We are looking for the peak red moment. If we harvest too early, it's bitter. Too late, and they begin to rot. The window is about 48 hours.
These peppers are reaching peak ripeness right on schedule.
These specific cultivars are bred to hit around 50,000 Scoville units. Hot enough to register pain, but carrying enough fructose to ferment properly later on. For delicate varietals, like Tabasco, the harvest is still done by hand. Workers use a Le Petit Bâton Rouge, a small red stick, to ensure every pepper picked matches the exact color requirement. But for mass-market sauces, speed is king. This mechanical beast harvests 20 acres in a single day, doing the work of 300 humans. Rubber fingers agitate the bushes, snapping the peppers off the stem. It's a violent process, but these thick-skinned cultivars are bred to withstand the impact. The output is staggering. Tons of raw product are collected every hour. But as soon as they are picked, the biological clock starts ticking. Once severed from the plant, the peppers begin to decompose. They must be processed within 24 hours, or they spoil. The logistics are as crucial as the farming. Night and day, during harvest season, a convoy of trucks creates a steel river, connecting the fields to the processing facility. The factory never sleeps. It is a machine designed to inhale raw agriculture and exhale a standardized liquid product. Every truck is weighed upon arrival. Farmers are paid by the ton, and the factory needs to know exactly how much raw material is entering the system to calculate yields.
Let me see the manifest.
It's all there, visibility officer.
Before unloading, samples are rushed to the on-site lab. They check for rot, debris, and ensure the Scoville heat levels match the farm's data. If it fails, the entire truck is rejected. Approved loads are dumped immediately. At peak operation, this facility intakes 40 tons of raw peppers every single hour. From the pit, the peppers begin their journey through the plant on a series of high-capacity conveyor belts, moving toward the cleaning stages. First, gravity and vibration remove the heavy debris, rocks, metal, and field dirt that got scooped up by the mechanical harvesters. Next, a high-pressure deluge cleans the skins. This isn't just a rinse, it's industrial scrubbing to remove surface bacteria and stubborn field soil. Human inspectors do a final manual check for large debris, but the volume is too high for eyes alone to catch everything. That's a job for robots. This is the optical sorter. As the peppers enter free fall, high-speed cameras and lasers inspect every single chili in milliseconds. The machine measures color consistency, density, and shape. It knows exactly what a perfect red pepper looks like, and it identifies anything that doesn't match the profile. When a defect is spotted, a precise blast of compressed air, timed to the microsecond, snipes the bad pepper out of the airstream, while the good ones continue untouched. The rejected material, greens, stems, and rot, is separated instantly. This ensures only ripe, perfect fruit makes it into the mash. What remains is a pure stream of vibrant red flavor, ready for the most violent part of the process. As a final safety check, the peppers pass through a highly sensitive metal detector to ensure no stray bolts or harvester parts have made it this far. Now, the peppers face the hammer mill. They are about to be transformed from solid fruit into liquid fire. Inside the mill, rapidly rotating steel hammers smash the peppers through a standardized screen. It's deafening, violent, and incredibly efficient. The result is mash, a coarse mixture of skin, seeds, and pulp. It's spicy now, but it doesn't have the complexity of hot sauce yet. Powerful positive displacement pumps move this thick, resistant material through stainless steel arteries toward the most critical stage, preservation. Salt is added immediately. This isn't just for flavor, it's the gatekeeper. It kills off harmful bacteria while allowing the good, salt-tolerant bacteria to thrive. The ratio must be exact. Too little salt, and the batch rots. Too much, and fermentation never starts. It's a delicate biological balancing act. The salted mash is pumped into these massive holding tanks. Each one holds hundreds of tons of potential hot sauce. This is the cathedral of spice. Millions of gallons of mash sit here, quietly doing the work that machines cannot. Lactobacillus bacteria, naturally present on the peppers, wake up. They consume the natural sugars and convert them into lactic acid.
The rod-shaped bacteria break down the crystalline sugars, releasing the lactic acid and carbon dioxide bubbles you see rising.
This acid lowers the pH, preserving the peppers naturally and creating that distinct, tangy, funky flavor profile that defines a fermented sauce. Depending on the sauce, the mash will sit here for anywhere from 1 month to 3 years. Time is the final ingredient. Science confirms what the nose detects. When the pH hits the target acidity and the sugar is consumed, the fermentation is complete.
The acidity levels are stabilizing right here. Good. The pH curve looks consistent with the aged sample.
When a batch is declared ready, the tanks are cracked open. The aroma is overwhelming, a concentrated blast of aged heat. The aged mash is pumped out of storage. It's stable now, but it's too thick and too salty to be bottled directly. The mash is transferred into mixing tanks that hold upwards of 10,000 gallons at a time. Here, industrial strength vinegar is added. This does two things. It dilutes the mash to the correct consistency and halts any remaining fermentation activity. Giant paddles and high-shear mixers run for hours, blending the ingredients into a perfectly homogeneous liquid. They test the viscosity right in the tank. If it's too thick, they add vinegar. Too thin, and they might add a natural thickener like xanthan gum, depending on the recipe. Once mixed, the sauce is fully flavored, but it still contains seeds and tough skin fragments that would clog a bottle nozzle. The finisher uses centrifugal force to press the liquid through incredibly fine microscopic screens. The seeds and skins are ejected. Nothing is wasted. This fiery byproduct is often sold as a base for pepper spray or animal feed additives.
The finishing machine extrudes a compressed cake of chili seeds and skins.
What's left is the pure essence, smooth, stable, and ready for the bottle. This buffer tank feeds the high-speed bottling line, ensuring constant pressure and uninterrupted flow. The bottling hall is where industrial speed takes over. Empty bottles are unscrambled and enter the line at a rate of 5 per second.
The rotary unscrambler takes these jumbled glass bottles and, through a high-speed centrifugal process,
Every bottle is inverted and blasted with ionized air to ensure it's perfectly clean before filling. This is the heart of the operation. The rotary filler fills 300 bottles every minute with clinical precision. Before the sauce can even cool, the caps are applied and torqued to the exact specification to create an airtight seal. Labels are applied at high speed. The bottle is now a finished product, recognizable to consumers worldwide. A laser etches the birth date onto every bottle. This batch code allows the factory to trace this specific bottle back to the exact field and day it was harvested. The final defense is an X-ray scanner, looking for any microscopic glass shards or imperfections that might have occurred during bottling. But machines can't judge flavor. Every few hours, a human sensory panel tastes the product against a gold standard to ensure it matches the exact flavor profile customers expect. If the pH is off by even a fraction, the entire batch is quarantined. Stability is key for a product that might sit in a cupboard for a year. Passed by human and machine, the bottles are finally boxed up by high-speed robotic arms. Cases are palletized and shrink-wrapped, ready to leave the controlled environment of the factory for the outside world.
This state-of-the-art robotics system can stack and wrap a full pallet in under 90 seconds, ensuring efficiency and stability.
From here, they are dispatched to over 50 countries. The journey that began in a dirt field is almost complete. It's a global phenomenon, a universal condiment that crosses cultural borders, bringing the same controlled burn to billions of meals.
Go ahead, try some of that sauce.
Wow, that is so good.
It really is the best, isn't it?
From a seed in the dirt to a barrel in the dark, and finally, to the bottle on your table. This is the modern alchemy of liquid fire.